So you want to solve this distance bearing problem on the board, which says that a boy walks 6 kilometers from a point P to a point Q on a bearing of 65 degrees. He then walks to a point R, a distance of 13 kilometers on a bearing of 146 degrees. We want to calculate the distance from P to R to the nearest kilometer, and then we also want to find the bearing of R from P. This is our question for the day. If you have not subscribed to this very channel, kindly do so for more episodes to come. So with distance bearing problem, the first thing that you are supposed to do is to draw your cardinal point. So these are north pole, and then this was our south pole. We have already learned that in bearing, angles are measured from the north in a clockwise direction. And we know that 65 degrees will fall in the first quadrant, right? So we are going to measure from the north till we get to this point, and then we draw our distance. So the boy walks 6 kilometers, so we have 6 kilometers from a point P. So the 4 is going to be this very side to a point what? Q. So this is point Q. He then walks to a point R, a distance of 13 kilometers on a bearing of 146. So we are going to draw our second cardinal point here. And from here, our north pole is still at this one point. Our south pole is still here, our east, and then our west. You know that 146 will fall in the second quadrant if you have to measure from the north in a clockwise direction. So it is going to fall here, and then we draw our distance. Now with the distance from Q to R, we are having what? 13 kilometers. Now we know that 13 kilometers is longer than what? 6 kilometers. Therefore, the distance from Q to R must be longer than the distance from P to Q. That is one thing you have to take note of it. So we have our R to be here. Once we are done with this, we are going to join P to R. So this is our diagram for the question on the board. Let's go through the question again to see if this diagram is in line with the question on the board. A boy walks 6 kilometers from a point P to another point Q on a bearing of what? 65 degrees. So this is 65 degrees. He then walks to another point R, a distance of what? 13 kilometers on a bearing of 146 degrees. We want to calculate the distance from P to R. So this is P, this is R. We want to find this distance. So let's call this distance X. And then we want to find the bearing of R from P. Now once you are done with the diagram, the next thing that you are supposed to do is to find your transit point and then your transit angle. That is how I used to call them, the transit point and then our transit angle. The transit point is at Q, and then the transit angle is the whole of this. So we are going to find the transit angle. Now with this particular angle, we know that applying the alternate angle concept, this angle is equal to this angle. If this angle is 65 degrees, then this angle will also be what? 65 degrees. Now let's look at this angle. This angle. You know that the measure of the angle from the north to the south pole. So from the north to the south pole is what? 180 degrees. And we are being given the measure of the angle from the north to this terminal. So from the north to this terminal is what? 146. So to find this small angle, we are just going to subtract 146 from what? 180. And that's going to give us what? 34. So this angle is what? 34 degrees. Now let's sum these two angles together. So we have 65 plus what, 34, that gives us 99 degrees. So the transit angle is 99 degrees. It is the transit angle which is going to tell us whether we are to use Pythagoras theorem or the sine and then cosine rule. If the transit angle is 90 degrees, we go for the Pythagoras theorem or the trig ratios. But if it is not 90 degrees, we go for what? The sine and then cosine rule. So we are going to make use of what? The sine and cosine rule. So with the cosine rule, when you have any triangle which is not a right angle triangle with these dimensions, then the length of A is given as A squared all over B squared plus C squared minus 2BC cos of the angle A. The same thing applies to B. We are going to have B squared minus B squared is equal to A squared plus C squared minus 2AC cos of the angle B. The same thing applies to C. So we want to find P and then what? R. So it means we are going to have what? X squared. So we have X squared is equal to what? 6 squared plus 13 squared minus 2, 6 multiplying 13 cos of the angle what? 99. So we have X squared. This will give us 36 plus 169 minus 156 cos of what? 99. So we have our X squared is equal to 205. This will give us 205 minus 156 cos of the angle 99. When you punch all of this on your calculator, you are going to get 229. We are looking for x, so we are going to take the square root on both sides of the equation. We can say that our x is equal to 15.14 kilometers. To the nearest kilometer, we are going to have our x is equal to 15 kilometers. That is the distance between P and then what? So we have 15 kilometers. Now the next question says that we should find the bearing of R from P. So this is R from P. So it means that we are going to measure the angle from the north till we get to this terminal line. We already know this angle, so we have to find this particular angle theta. And we can do that by applying what? The sine rule. The sine rule. So with the sine rule, we are going to have x all over the angle sine of the angle 99 is equal to 13 all over sine of the angle theta. So we are going to have sine theta is going to be what? 13 multiplying sine 99 all over x. And we know that our x is what? 15 kilometers. So let's bring our 15. So you can say that our theta will be given as sine inverse of 13 sine 99 all over what? 15. So when you punch all of this on your calculator, so we are going to get 58 degrees. So we know that this angle theta is equal to what? 58 degrees. So the bearing of R from P will be given as 65 degrees, which is this angle, plus angle theta, which is 58 degrees. And as easy as that, this brings us to the end of today's lesson. See you tomorrow. Bye bye.